Are we good,
Okay,
Jessica?
well, I think we're good to go. Good morning, everyone, and welcome. This is the Clean Cities Team Northern Tier, or TNT as we like to call ourselves. We've got Peggy O'Neill Vivanco in Vermont. I'm Jessica Wilcox in New Hampshire, and we have Sarah and John from Maine Clean Communities. We're part of the Clean Cities Northern Tier team, and we're bringing to you today another webinar in our medium and heavy duty webinar series. This one on heavy duty electrical vehicle charging. And we're hoping that it does spark plug ideas for you all on the call today. Next slide, please, Peggy. So just a few logistics before we get started. You've all been brought into this Teams webinar. Please make sure that your audio is muted and your video is off so that we can give the spotlight to all of our presenters. Feel free to communicate and type your questions and comments in the chat as we go. In fact, we'd love to know who's on the call with us. So why don't you start putting your name and title and your organization into the chat now so we know who's with us today. This webinar is being recorded and we will be able to share that with you after the webinar. Next slide, please, Peggy. So as I've mentioned, we're the Team Northern Tier for the Clean Cities Coalition. We've got Peggy with Vermont Clean Cities. I'm Jessica with Granite State Clean Cities in Vermont. And we have Sarah Mills-Knapp and John Gagne from Maine Clean Communities with us. And we're all your sources for any Clean Cities information. So anything alternative fuels and electric vehicle related. Next slide, please, Peggy. And we're not the only ones. In fact, the Clean Cities program is a nationwide program supported by the US Department of Energy. And there's pretty much a Clean Cities coalition in every state. What does that mean for you? That means you have multiple opportunities to connect with Clean Cities. And not only that, but we have multiple resources beyond throughout the nation that we can serve us to help answer your questions and get you connected to other fleets that are doing these types of projects and other vendors that are offering these types of products. Next slide, please, Peggy. So Vermont, Granite State, and Maine Clean Cities, we all work together collaboratively, but we also work independently within each of our states. A lot of what we do is focused on alternative fuels, vehicles, and equipment in terms of supporting fleets, managers, businesses, and municipalities that are interested in adopting these types of vehicles and technologies. We also work on fuel efficiency and emissions reduction efforts. So think telematics and idle reduction. We connect fleets with fuel providers and industry partners. We collect a ton of data and tracked project progress. In fact, we're going to be launching our annual report outreach where we collect data on projects around our states and report that to the Department of Energy for greenhouse gas emissions reductions and fuel reduction as well. And as we're doing today, we're providing education and outreach to our partners and our stakeholders. Next slide, please. So let's launch a poll. What we'd love to know from you all is, are you currently looking for an electrification option for your heavy duty vehicle in your fleet? Whenever you're ready, Peggy, we'll go ahead and launch that. No problem. So the options are going to be, yes, you are looking and you have a solution in place. Yes, but you're struggling to find the right solution. You are exploring solutions, or not at the moment. So hang on one moment as we get that poll launched.
Just give me a second. I have two
Yep.
new screens open. John, and I'm letting people in still. John, can you help me launch this, or is it all on my end?
Yeah, unfortunately, I think it's all on your end. On the polls tab at the top.
Yeah, that's where I have the polls and launch.
And I will get back to you as soon as I have anything on.
Okay.
All right, you should see that poll pop up. I see it on my end, so go ahead and start responding. Looks like so far we have 8 responses. Are you guys seeing the responses to the poll? I'm only seeing yes or no.
I'm seeing just yes and no. It was initially
Maybe
yes
put
or
them on-
no, but then it finally did come up over on the right to match the screen of the 4 options. At least it did for me.
Yep.
Maybe click the polls button to make it go away and then click the polls button again at the top to have it refresh. That's what worked for me.
Okay, yeah, I'm seeing results on my end, so,
Can you share those, Peggy? For some
Uh,
reason, I don't
I-
have access to them.
Yeah.
my God.
I can
Can-
see it.
Can you-
Yeah, it looks like we have 57% who are exploring solutions. So just starting to try and figure out what might work in their situation. And we have 6% who have a solution already, which is exciting. And then 26% who are not looking at the moment.
Okay,
Excellent. Thank you
all
so much.
right, okay, I'll go ahead and, close that poll.
And I think it said only 15 people responded for whatever that's worth.
Okay.
If
Well,
you didn't get a chance to respond, we'd love for you to input that in the chat feature. So go ahead and feel free to keep that correspondence going in the chat. And Peggy, over to you to introduce our first presenter.
all right, well, thank you all so much for attending. I'd like to introduce Tom McDonald, the Senior Director of Product Marketing at Wave. Tom's role at Wave is to keep medium and heavy-duty fleet operators informed about wireless charging and overcoming perceived barriers for electrification. Before Wave, Tom held product management and marketing positions for Apple, Autodesk, Motorola, and several other startups. He has a Master's of Education from University of Illinois and a Bachelor's of Communication from Bradley University. So from the Midwest, Tom is going to talk about Wave and these kind of exciting charging infrastructure that we can begin to consider. So Tom, would you like to take, I'm going to stop sharing and you will share your screen, okay?
One more time. Can everybody hear me?
Yep.
All right. Let's do this. And we'll do this. Can everybody see and hear this? Hear me and see the slides?
Yep.
Okay, good. Thanks. And thanks, Peggy, and thanks everybody for the opportunity to speak to you today about high power wireless charging for medium and heavy duty EVs. We were asked today to speak about the unique challenges of rural routes and northern climate, but regardless of whether you're speaking to fleet operators in Vermont or Hawaii, there's kind of this universal problem that everybody is looking to solve. And it really comes down to how do we get our electric vehicles to go as far as internal combustion vehicles? And unlike a decade ago when electric buses and trucks were struggling to complete routes, there are multiple solutions to the problem today. An electric bus manufacturer, for example, is offering today a 738 kilowatt hour battery. In optimal conditions, that will get you close to the range of a diesel bus, but the cost and the weight of a 738 kilowatt hour battery would likely be prohibitive to some. Further, we know that cold weather can take a big dent out of what optimal mileage is. So that can be a big variable to kind of plan around. Another zero emission solution is obviously hydrogen fuel buses and trucks. But regardless of whether you're trucking in hydrogen, what you usually do with diesel trucks, or decide to spin up your own hydrogen plant, hydrogen comes with considerable startup and maintenance costs, neither of which look unfortunately to be changing anytime soon. Nor does the fact that on a per mile basis, hydrogen costs much more than battery electric power. So what we think is maybe we need to change this question around. So instead of asking how do we get our electric vehicles to go as far as diesels, what if we change the question to how do we enable electric vehicles to go beyond their fuel capacity? Because for that, there's a solution. Now, you don't necessarily need to know your planes here to guess what's going on. That's a KC-36 Stratotanker refueling an F-16. This is a proven, albeit expensive technology that enables vehicles to stay in operation beyond their fueled range by adding energy within their operational duty cycle. This is the same concept. This is a bus, electric bus, charging automatically while it's en route, enabling it to transfer well beyond its 155-mile stated range. But in this case, instead of a physical connection dispensing the fuel, electromagnetic induction is being used to transfer energy from the ground assembly pad over an air gap with no physical connection to the vehicle. And unlike mid-air refueling, this is also a proven technology. This is one of 12 250 kilowatt on-route charging systems deployed at Antelope Valley Transit Authority in northern Los Angeles County. Now, I understand that Vermont is not California, but stick with me and I'll try to close that gap for you. The first systems here were installed in 2018, and this is now the largest high-power wireless charging system in the world, at least that we know of. And it's powering what is today the largest deployment of heavy-duty electric buses in the United States. And that's not a coincidence. In March of this year, AVTA became the first entirely zero-emission transit fleet in North America. Now, that's 18 years ahead of schedule in California, their scheduled 2040 mandate. So their buses cover routes as long as 300 miles. There's no hydrogen, and it's a relatively modest 324 kilowatt hour battery. So rather than give you more things to talk about, I'm going to attempt here to share a video. Hopefully you'll get the audio on this. You guys hear the audio on that?
No.
Not yet.
No? Oh, all right, give me a minute. I'm going to stop sharing and then start sharing again, because I think I forgot to hit that button. I apologize. One more time. Here. Ooh,
There.
computer sounds. There we go. All right, one more second. Good. Everybody hear that?
I don't hear any sound. Maybe others do.
I don't hear it. There's
Any-
There's
closed
captions.
captions.
I think,
Yeah.
I think we can do it without the sound.
All right, I'm sorry. Please read along. Apologize again for the audio. I'll make sure everybody gets a link to this. Hope everyone was able to kind of get their head around that. I'll move a little quicker here too. Founded in 2011, our first systems were 50 kilowatt systems that were deployed in 2016. Those are still operational. We've got the longest running and largest deployments of wireless charging that we know of, spanning 50, 125, and 250 kilowatts. We were acquired by publicly held Ideanomics a couple of years ago. That gave us money to scale into new markets such as ports and distribution warehouses. All of our transit customers up here on the right are repeat customers or soon will be. The system down at St. Pete at PSTA just back in October went through Hurricane Ian unscathed. We've also got several truck deployments, including systems at the Port of LA, because a lot of the problems that we solve for moving people, we also solve for moving goods. So what are those problems? What are the problems that wireless charging solves? First, I want to make sure that as I go through this, I'm not necessarily saying there's no role for conductive charging, or am I advocating everything should be entirely wireless? In certain applications, certain duty cycles, in certain environments, there are benefits of wireless over others. So I want to make sure I'm making that clear. And one thing to note too is that, you know, when we talk about wireless, we know for a fact we don't necessarily need to plug something in to transfer power, right? We have our phones that charge wirelessly, our toothbrushes, and even though they rest in a holder, there's no necessary contact that has to be made. The electric charging has happened by an electromagnetic field that's induced by the charger. But conductive chargers do require contact, and they do require manual refueling. And because the energy density of lithium-ion batteries is lower than that of fuel, it requires more frequent plugging, more manual labor. In this case, you can see there's 2 plugs that have to be plugged into that bus. Sometimes they're heavier cables or liquid-cooled cables. And all that plugging and unplugging presents another challenge, which is plug-in connectors are prone to wear. Heat causes expansion, contraction, dirt, dust can interfere with contacts. That causes problems. The New York Times is one of several outlets early last year that highlighted some of the problems. And these problems scale accordingly when you're talking about charging large EVs, which require more amps and more frequent plugging in. And of course, as we talked about, the plug-in chargers, you have to take the vehicle out of operation to charge it, which could disrupt operations or require extra vehicles. In a temperature-controlled environment like a garage with a short duty cycle, maybe plug-ins will probably work just fine. But what if you're in an 18 or 24-hour duty cycle in harsh environments? That's where you start to look at wireless. As the video showed, these large semi-automated pantograph chargers can reduce dependency on plug-in chargers for transit agencies, but they're huge. This is an awful lot of hardware to just simply automate charging. This is a trial down at Chicago's lakefront. That's just for a single bus. Imagine if all those stations there had pantograph chargers. You wouldn't even be able to see the skyline. Obviously, these mechanized systems have problems in cold weather. You can see that this is likely not functioning. That's a pantograph charger in Duluth, Minnesota. And of course, because they are highly mechanized, they require a lot of maintenance. That requires people up on bucket trucks, high above the ground, going up there frequently to maintain those systems. So what does wireless offer? It's fully automated, cable-free, and it's easy on the eyes. It works through snow, rain, ice, and even hurricanes. With no moving parts, it's proven to be highly reliable and easier to maintain than many of these conductive solutions. How does it work? We take a 43-phase AC grid, which is typical for charging systems. We wire that to our power cabinets. That then gets wired to a ground assembly pad that's embedded in the pavement. And using transit as an example, the operator would pull in, they align the bus with pavement markings. Charging occurs wirelessly when there's a handshake between the ground assembly and the vehicle. The vehicle's immobilized. Within seconds, a magnetic field and the ground assembly induces an electric current. on the assembly plate mounted on the EV's underside, which that battery is then sent to, that power is then sent to the battery. It's worth noting too that this process is entirely automated, so there's nothing to forget, and all the vehicle's auxiliary functions function as normal, and the efficiency is equal or better than that of even a conductive charger. That's something that a lot of people assume, that the energy transfer is inefficient, but it's actually equal to most conductive chargers. And charging ends when a brake is disengaged or the battery management system ends the charging cycle. At 250 kilowatts, you can get about 10 to 15 miles of range on a Class 7 40-foot bus. Do that 7 times a day, that's 70 to 100 miles. So minimally, you're getting 45% more range on a 155-mile bus, which is significant. Wireless applications, I'll go through these quickly. Maritime ports. If it's above ground, somebody's going to hit it. Flush to the ground, that means there's nothing to collide with. It's fully automated to address the safety concerns of people handling high-power cables. Certainly in port environments where you have salt water, being embedded in the pavement in a stainless steel case is resisting against the elements. As far as, what am I not advancing here? Having a problem, sorry. There we go. Warehouse and distribution, a lot of the same things. Embedded pads in the loading dock, there's not a lot of space. Oops, looks like I had a delay. Pavement embedded pads fit at the existing loading areas, so there's no extra construction or having to remove areas. Duty cycles kind of align well with the need to charge, and it allows these warehouses to more easily meet their carbon neutral pollution goals quicker when you remove the barriers. Mass transit, we kind of talked about. How does this translate to reducing fleet costs? So let's take an example of a situation where I've got a bus that's $780,000 and it gets about 150 miles of range and it weighs around 32,000 pounds. Typically, that's not going to be enough. So you see a transit agency or a fleet operator want to add more battery. There's a diminishing point of return there, because as you add more battery, you add more weight, which decreases the efficiency. With wireless charging, we're actually able to reduce the battery size because we can charge it en route or charge it during scheduled stops. That lowers the bus cost, so scale that over the whole fleet, as well as reducing the weight, which of course has an impact on consumables such as brakes, suspension, etc. Did I hear somebody say something? Okay, just quickly, I want to wrap up. So I talked about perpetual operation. I could spend 20 minutes on the slide, but in summary, this is a bus that actually during the day, you can see it actually gained state of charge throughout the day because of the way the chargers were placed. The state of charge actually goes up. It ended its 8-hour shift with an 80% SOC. It had enough charge to actually go out and do another evening shift. It only charged once because that's all it had to do. And it ended its 17-hour day with a 42% SOC. Had it charged in the evening, it could have basically run perpetually. So you want to talk about the ability to get buses or trucks to go as far. Again, the solution is to keep that charging en route during those duty cycles, just like we talked about in that airplane. So just a quick summary. Wireless charging more easily enables medium heavy duty EVs to meet the diesel range. It reduces total cost of ownership via smaller, lighter battery packs and lower charger maintenance and operation costs. And it's more resilient in harsh environments, snow, wind, cold, and even hurricanes. I'm going to make sure that everybody gets case studies and as well as a link to that video.
Thank you. Thank you so much, Tom. I'm wondering, John, do you see, let's throw Tom maybe one question from the chat, then we'll move on after he responds, and we'll have more time for questions at the end, but just one for Tom right now.
Sure. Would these wireless chargers be feasible for school buses on the loops waiting for children?
Sure. Yeah, absolutely. The challenge with some, can you guys hear me?
Yep.
Yeah, so the challenge with school buses is they tend to sit for long periods of time and over weekends. And there is plenty of opportunity to plug in a bus during that time. What we like to talk about is wireless addresses the challenge of when there isn't a lot of time, when there is a long, arduous duty cycle that's continuous. So certainly the technology is applicable, and we do have interest. But typically, when you look at the cost of wireless charging and the opportunity to plug those in, it may be more feasible cost-wise to just have somebody plug those buses in if there's a plug-in charger available. Does that answer the question?
Yeah, that makes sense.
Yeah.
Okay.
Thanks, John, and thanks, Tom. So, Tom, we're gonna move on. Again, there'll be more time for questions at the end, but get ready for these snow and ice questions from Maine, New Hampshire, and Vermont. So, let me introduce Tiana. You took control.
I did.
Okay. So let me introduce Tiana Smith from Green Mountain Power. She's relatively new to Vermont, coming from Colorado, and spends a lot of time skiing up in Smugs with her family. So Tiana, you want to take it over and share kind of the utility perspective about charging and what our fleets need to consider. Thanks.
Absolutely. Yeah. Thank you so much for having me. Definitely a bit of a different perspective. And I'll be talking today really about how we help fleets transition and then a little bit about our own fleet transition. So just a couple of slides here. But let me start by telling you a little bit about Green Mountain Power. We serve about 75% geographically of Vermont with about 510 employees. We have 15 offices all around the state, and more than half of our members, we're very proud, are IBEW members of the union there. So really, we are all about cutting carbon, cutting costs, and boosting resiliency. We have dozens of programs, not just around electric vehicles, but to help customers electrify, and in doing so, save carbon and in costs. Last year alone, we cut about 210,000 metric tons, or the equivalent of taking about 45,000 ICE vehicles off of the road, something we're also very proud of. And another unique thing that you may or may not know about in Vermont, but our energy supply here is 100% carbon free today, and 78% renewable today, with plans to be 100% renewable by 2030. You may be wondering what that differential is between renewable and carbon free, and today that is nuclear. So nuclear is carbon free, but not renewable, but moving towards that 100% by 2030. So obviously an amazing opportunity for any of our residential or business customers that that want to electrify, meet their sustainability goals. Our energy supply can help really catapult that. So as you know, not a surprise, what's causing Vermont's emissions, and this is true really across the nation, is driving fossil fuel vehicles and then also heating. So building heating with fossil fuels, that's what that looks like in Vermont, but that tracks really closely. Oh, is somebody not seeing my slides?
I think some of us are. So
Oh, shoot.
whoever just asked that question, are you seeing them now?
Are others seeing it?
It looks like others are seeing
Okay.
it.
Okay, great. Sorry about that. So already talked about this, but we have the cleanest electricity in the US. Great tool for us to reduce carbon for our customers. And then another really unique thing here in Vermont is we, and I think that this may be a different business model than other electric utilities, but we are regulated, and we do not make money off of our kilowatt hour sales. So all of our the way that GMP makes money, you know, we hear from people, of course you want people to electrify because that means more revenue, but actually it drives down the unit cost for our customers. We spread those savings across our entire customer base because the way that GMP makes money is through capital investments, important investments for our infrastructure. And so when we have more customers using more kilowatt hours, it actually reduces costs for all of our customers. So right now we have lots of ways that we help customers do this, and it's not just for heavy duty, although we're really excited whenever we're approached by a commercial customer, industrial customer looking to transition their fleets. We have rebates that help with that, up to $3,200 depending on income for residential customers. We do it a little bit differently and on a custom basis for our business and industrial customers. Using tier 3 money that we have through our renewable energy standard. We also have discount EV charging rates and are about to pilot a commercial EV rate as well for fleets that are able to actually control their load. And then we are free home chargers for any of our residential customers, and then also work on, we have a workplace charging incentive and support with fast charging as well for our business customers. Working really hard to expand our fast charging network across the state. Workplace charging, I just mentioned, and just lots of ways in which we can support customers on a really tailored and individual basis that come to us and look to transition their fleets. And then we're also looking to transition our own fleet. So by 2025, 100% of our cars and SUVs and 25% of our light duty trucks will be fully electric. Remainder of our light trucks by 2029. We do have I jumped ahead. We did receive a really large grant from the state, thanks to the Volkswagen settlement. We got about $915,000, and through that we were able to purchase a rack truck, which we currently have in operation, and we have a bucket truck that's going to be coming in the next, I think, month, so that we can start to really pilot our own use of heavy duty electric vehicles. And so very excited about that, and you know, obviously helping customers transition those fleets as well. We have technical expertise. We work with various, you know, large commercial and industrial customers on whatever their needs are. We have lots of partners across the state, and yeah, I'm happy to kind of speak more directionally if people have questions about how we help large and heavy duty electric vehicle transition. But that is all I have right now.
Thank you, Tiana. So just one question for you before we move on. Again, we'll get to some more at the end. You know, I'm biased because I'm from Vermont. I work a lot with GMP, but just to explain, like, you know, when fleets are even considering, you know, even a small business, at what point should they be in contact with Green Mountain Power as they're considering even some of these charging pieces? Like, which comes first, the charger or the vehicle?
Yeah. So what I would say is the second that businesses are thinking about that transition, to reach out to us, because we really have a turnkey solution from, you know, even we have one particular customer we're working with right now, a nonprofit, that basically came to us and said, hey, we're about to start a fleet. We'd really like it to be all electric. How can you help us do this? And so through technical expertise, both on the charging side of things and then also on the incentive side of things, we're really able to help them comprehensively with, you know, what vehicles should we be choosing for, how far the range is going to be, what should the software solution look like for managing the charging across the fleet. You know, just reach out to us and we can help really from idea all the way in through installation.
Great, thank you. Soup to nuts.
Yeah. And I'm happy to answer a couple of these other questions within the chat too.
Okay, thank you.
Great.
All right,
right.
I'll jump in again. Thank you, Tiana. Once again, I just want to reiterate to everybody that is watching, please feel free to type your questions in the chat as we go. John and Sarah and I are monitoring the chat. I think I copied somebody's question over onto my spreadsheet and happened to inadvertently give it a emoji symbol. So I changed that to a thumbs up just because I can't seem to get rid of it. But thank you for your questions, and we continue to ask that you put them in the chat, and we'll keep track of them as we go. So up next, I'm pleased to introduce Scott Bradley. He is the Director of Sales with Pioneer Power Mobility. Now, Scott has over 20 years of technology and energy industry experience, so a wealth of knowledge. He meets regularly with all of the major electric vehicle truck manufacturers and charging community companies, so his finger is on the pulse of what is happening. Scott holds a degree in electric engineering and interestingly, a master's in robotics and artificial intelligence. Scott, I'll have to have a chat with you offline there. but thank you for being with us on the call today, and we're excited to hear more about your mobile charging solutions. Go ahead and take it away, Scott.
Great, thank you very much. Looking forward to talking about heavy-duty electric vehicle charging. Now, what I'm talking about today, it's applicable to light-duty, medium-duty as well. But of course, with the scale and size of heavy-duty, there's some extra things that we look at for heavy-duty. So that's what we'll focus on today. Now, there's no doubt we're in the middle of an electric vehicle revolution. If we look at Tesla's exponential growth compared to how the Model T grew, we can see just how rapid and how pervasive this is in terms of moving to electric. Now, this is also paralleled in the electric vehicle truck area. So if we look at large vehicles, light duty, medium duty, heavy duty vehicles, there's 75 new electric vehicles that came out in the last 5 years, another 50 coming out in the next 3 years. So the options are tremendous. And what we need to do is look at not only how to buy the vehicles, but of course, how to charge them. Now, electric vehicles are not all new. If we look back at 1935, the Walker Electric was used by the UPS company. Of course, there was a brief rise of electric vehicles early in the last century that then moved away. And now, though, we're seeing that movement into vehicles from light duty, medium duty, and heavy duty, all electrifying, all having slightly different charging needs. So a brief background in Pioneer. So we've been around 30 years. We actually started out doing low voltage switchboards, medium voltage powerhouses, a lot of switchgear, automatic transfer switches, and a lot of critical power. So backup generators and service. So we actually do all the backup power for all the Target stores nationwide. So next time you drive by a Target in Vermont, New Hampshire, Maine, think about Pioneer because we're doing their backup power. And then in 2020, we came out with 2 new divisions. One is E-Block, which is a microgrid division, basically large battery pack and switchgear that then can connect up to solar panels, to wind, to the grid, to backup generators to charge, as well as E-Boost, which we'll look at today. And that's for off-grid electric vehicle charging. How do you charge your vehicles before you actually get connected up to the grid? So one of the challenges that we see time and again is that charger installations are very much aligned with the grid infrastructure. And the more rural you go, the more remote you go, the harder it is to get sufficient power for the larger vehicles. There's some locations even that just won't have sufficient power going forward. And although most may need a temporary solution, some may need a more permanent solution. So as it was mentioned earlier, I have the opportunity to meet with all the major truck manufacturers on a regular basis. This is looking at one of the systems that is actually OEM'd by one of the electric vehicle manufacturers.
Scott, I'm sorry to interrupt, but it looks like you stopped screen sharing or stopped presenting it.
Yeah, it looks like it just stopped sharing.
So let me reshare and then you can take control again, okay? Give me a
Okay,
second.
great.
You may have to advance the slides a bit. Hang on. Okay, so take control now from me. Can you take control, Scott?
Yeah, I'm trying to. It's not.
Okay.
It's not giving a little button to take control.
Now it shows your kind of your calendar.
To my calendar.
Yeah, I'm happy to advance your slides for you if you're having some technology challenges. This might be like
Yeah.
the Luddite leading the Luddite here, but
Yeah, just not allowing me to advance.
okay. Do you see? So well, right now we're still on the propane tank, mobile charger, and the international truck. Is that where you want to be?
That's perfect. So we work with a lot of electric vehicle manufacturers to allow them to actually do ride and drives where there isn't yet infrastructure in place. Oftentimes, they'll also then provide this off-grid electric vehicle charging to their dealers, who can then provide it to customers for their pilot projects when they first get their first set of vehicles. All right, next slide. Now, one of the biggest challenges, and we work a lot with fleets, is the time it takes from the time you want power to getting power. And as was mentioned earlier, it's very important, as soon as you think about getting electric vehicles, to reach out to the local power company to understand how long it will take to actually get sufficient power to where you need to go, right? Looking at what kind of trucks you're implementing, what kind of dwell time you have, how fast you need to charge them, and get an understanding of the full amount of power necessary. Because what happens often is with the incentives that are being given, people are very quickly going out to buy the nice new shiny trucks, buses, et cetera, that are electric, take advantage of those incentives, but only once they acquire them are they thinking, wait a minute, how am I going to power it? And it can take a year, it can take 2 years to get the power up in place due to supply chain issues. If you've got a lot of companies in the same location trying to get power, you get queued. So we work with a lot of companies from the time they get their first electric vehicle to the time where the electric grid is actually connected up. Next slide. So this is looking at one of the off-grid electric vehicle charging solutions. Now, what I want to look at is not this one necessarily specifically, but that it has the building blocks of all different types of electric vehicle charging. Next slide. So in this case, it has a 240 kilowatt fast charger, a couple level 2 chargers, a 300 kilowatt propane generator, and 6 propane tanks. In addition to that, next click, it has an eBoost Realm, which is real-time monitoring of all these devices. We hear often about chargers not working because we are often in remote areas, because we're off-grid. The chargers really need to work all the time. So we're monitoring the chargers in real time to make sure they're working. We're monitoring the generator to see when does it need servicing. And we're monitoring the propane levels so it can automatically go and ping the local provider to bring in propane. Next. On top are solar panels for the parasitic loads. This means that chargers are always pulling some power. Even when they're, quote, off, they're still pulling some power. We also use an LTE mesh, so we're doing a cell signal up to the closest AT&T or Verizon network. Now, if you are far in northern Maine and you don't have a good cell signal, we also do it using Starlink satellites. So no matter how far you go, how remote, the off-grid charging works. And then, of course, lighting and security cameras. So in addition, this unit, because it has a large generator, it actually has a voltage selector switch. So it's actually being used in this case also for backup power for a building. So not only charging cars, but backup power in case of an issue. And therefore, there's a voltage selector switch for 480, 240, or 120 volts. Next. And this is just another way of looking at it. It's really just building blocks, right? So you can start very small with maybe a 30 kilowatt charger, or you can go up to doing multiple fast chargers. Next. So when we first started looking at off-grid solutions, our first thought was, how about hydrogen? It's extremely clean, very low carbon intensity, but very quickly you realize it's expensive and difficult to transfer, and also very difficult to find in the volume necessary, and especially in remote locations. So that brought us to propane, which is a green fuel, and about half the carbon intensity of the grid. Now, the great thing about this audience is we are talking in about Vermont, New Hampshire, Maine, where we have 3 of the 5 cleanest grids. Next. So if we look at New Hampshire and Maine grid, what is coming with propane now is renewable propane. It's available in California, in New York, in Vermont, coming out to the next 15 CARB states as well, and has a very low carbon intensity. Now, if we look at the outlier, Vermont, which we know is the cleanest grid in the nation, and hats off to Green Mountain Power, there is an additive called renewable dimethyl ether, and this has a net negative carbon intensity, which mixed in with renewable propane brings it down to a net zero carbon intensity. So propane is clean today, cleaner tomorrow. Next. So there are many different shapes and sizes for the off-grid charging, really depending on what the need is. Some, like the first column there, the eBoost Mini, are brought in electric trucks for their ride and drives or for customer pilots. Larger units that might go from 50 to 240 kilowatts are done in trailers where they can be charging up multiple vehicles. You might do 2 18-wheelers, charge them up, or you could do 6 smaller cars for very fast, rapid charging. Then in the pod side, it's really for the NEVI model. So it's the alternative fuel corridor. If you're going to a location where you're putting in power solutions for charging, but there's no grid within a mile of that alternative fuel corridor, you can use these eBoost pods that go up to 600 kilowatts of power on 450 kilowatt chargers, which is, of course, the requirement for the NEVI model. And then on the right, we see eBoost Goat. So what happens if it is a city bus and it's at its furthest point in the route and someone didn't fully charge it the night before? The eBoost Goat is kind of like a AAA model, right? It's that emergency charging comes on the back of a truck and gives you a fast charge so you're off and running again, so that you don't have to have any kind of range anxiety out there or concern about the cold. Next. So again, I meet with the electric vehicle truck companies on a regular basis. When I sit down with them, I always look at what are their models. So here we have Daimler's Class 8, Class 7, Class 6 vehicles. Of course, the range is critical to you as a fleet. And then I look at battery size and how fast do they want to charge it. So the truck manufacturers are always talking about how fast they can charge, right? In this case, the eCascadia can be charged 80% in 90 minutes, which is phenomenal. What I look at, and like half my job is walking fleets back away from the power cliff. I need more power. I need more power. Well, how much power do you need? Because if this vehicle has an 8-hour dwell time at night, now instead of needing 240 kilowatt charger, you can do it with a 60 kilowatt charger. And that gives you the ability to charge more vehicles over that longer period of time with less power. Next. So in this case, we see with the Peterbilt vehicles, what I've done is looked at what their fast charge time is and what kind of charger is needed in terms of, in this case, for a 3-hour charge time, it's 120 kilowatts per charger. But if they have a 9-hour overnight dwell time, then they can drop it down to 40 kilowatts. So it's always a balance of how much power do you need to charge the vehicles, and of course, how much time do you have to charge them? Next. And I also look and talk with the city bus folks as well, doing the same kind of math. Now, in this case, with them, and actually all EV manufacturers I talk to, one question I always have for them is how fast do you go 0 to 60? And what's interesting is the Proterra fleet will go 0 to 60 in about 6.2 seconds. Now, I don't think it's something you're going to be experienced on your daily commute, but it's always fun to see how fast they can go. Next. So here we see a number of different options for the electric vehicle charging. Everything from the small, let's say 30 kilowatt charging on the left, upper left, to the upper right that could go from 60 to 100 kilowatts, the lower left, which will go up to 240 kilowatts or even more, and then the AAA type of model. Next. So a couple of quick slides on implementations. So if you were charging your 18-wheelers here, charging the tractor portion, this is how it would lay out in a depot. Next. And then, for instance, with your last mile delivery, where in a weekend, the power unit can be rolled in. There are skids with the chargers on them, so you're not digging up the land itself. So another reason people use off-grid electric vehicle charging is not only that gap that exists sometimes between when you buy your vehicle and you get the permanent infrastructure in place, but there are a lot of organizations that are renting or leasing the land that they're on. They may lease vehicles, they may lease the land, and actually not want to put in the cost and pay that cost to actually put in permanent infrastructure, or it may be a battle between the landlord that may not want the land dug up. So the off-grid electric vehicle infrastructure allows you, again, in the weekend to roll in power, put in a set of skids, and be charging up by the next day. Next slide. So here you see my contact information. If you want to link in, you can scan this on the right on your phone. This was from a journey we did from Atlanta, where we started out at the Bluebird bus dealership and drove up to the Port Authority up in JFK. And in the middle, we stopped by Mack Trucks in North Carolina. This is one of their Mack electric dump trucks, trash trucks. And we came in to give them a boost during one of the demonstrations. So with that, thank you very much. I appreciate your time.
Thank you so much, Scott. That was a great presentation. Appreciate the fact that this is mobile. And I think, as Vermont and New Hampshire and Maine Clean Cities are working on trying to implement some heavy duty demonstrations here in New England, it's nice to know that if we were to want to do a demonstration, there's a way to get a charging station up there. But I think for some of these more remote sites, it's been challenging to try to think of how can we connect these vehicles to charging. I don't see any true questions in the chat beyond maybe a couple that you might want to respond to in the chat, Scott. So if you're okay, we're just going to go ahead and move on to our next presenter. And Peggy, I'll have you come back online to introduce them.
Great. Well, without even planning that, that was like a nice segue from Scott, who was talking about the Mack electric refuse trucks, to introducing Jeff Well, Director of Communications from Casella Waste Systems. Casella works, in all our 3 states and beyond. And as many of you know, they recently launched an electric refuse truck. So Jeff is here to talk a little bit about fleet electrification, and I'm sure there'll be many questions about that electric refuse truck. All right, Jeff, welcome, and thank you very much.
Great, thanks, Peggy, and thanks for having us on today. I am stepping in substitution for our Vice President of Fleet, Mike Wilson, who was called away by a family emergency. So I guess my call to everyone today is to let you know that if I can't answer some of your questions today, I'm happy to take them by email and work with Mike to make sure that we're answering all questions possible. So a little bit about us, if you are unfamiliar. Casella was started in 1975 as a single truck operation. And, over the years, we've really grown through a sustainability lens into being the largest recycler in the Northeast. 1977, we established the first recycling facility in Vermont. And since that time, we've really made efforts and been on a sustainability journey to understand, how we not only can impact our own sustainability, but also empower others and effectively move them along their own sustainability path. So, we're exceedingly proud of the growth that we've experienced. We now have over 3,000 employees throughout the country. And, what we're here to talk about today, we have over 1,000 collection vehicles on the road today, primarily diesel, with one exciting exception that's been launched in Vermont. Just a little bit about where we are. I think a lot of people know us as maybe their hauler or their recycler of choice. Certainly operate some disposal sites throughout the Northeast, but really we have additionally, we serve customers in 44 states through just being on site and helping them with their sustainability efforts. So a good example that we use in this space is Becton Dickinson is one of the world's largest manufacturers of medical devices, pipettes, syringes, things like that. What we've done with Becton Dickinson is go right into their manufacturing areas and create circularity where before there was waste streams. And we've taken them from about 50% to landfill. Now they're all the way down to, in some instances, completely circular economy in some of their facilities. So, I think I bring that up because this is sort of a next step in an evolutionary path that we've been on. And a little bit about this is probably a bit difficult to read on the screen, but one of the highlights here, and really one of the jumping off points for us to think about, our greenhouse gas emissions, our carbon footprint, was in 2005 when we joined as a charter member of the EPA's climate leadership. And in 2012, we were honored as a leader in that regard by lowering our carbon footprint by about 45%. We're now on another path to lower that by another 40% from the 2010 benchmark by 2030. And, we're really looking at, not only things like landfill emissions and how we capture that gas, methane gas, and turn it into energy, renewable natural gas, but also how do we scale our fleet through electrification. And we're excited that we're in the pilot phase here in Vermont. We successfully launched our first electric refuse vehicle in Vermont. And the expectation here is that that's going to equate to about 7,500 gallons of diesel fuel annually. And, you know, if you think back to, we've got 1,000 collection vehicles on the road, you know, that's a compounding factor that, you know, we're very excited about. It's the equivalent to taking about 16 passenger vehicles off the road. And anytime that you can have that compounding effect of 1,000 vehicles, up to 1,000 vehicles, that's significant. And we sort of view Vermont as an excellent proving ground. The hills, the mountains, you know, the cold weather, and certainly the changing temperatures are an opportunity for us as well. You know, we've seen, you know, it go from 60 degrees down to 10 degrees in the snap of a finger, even here in January. So understanding how the vehicles perform in those conditions, understanding what that means for our operators and our customers is very important for us to test out through this pilot phase. So we're excited to have it on the road here in Rutland. That's where our charging infrastructure has been installed. The first of 2 trucks is on the road currently, so we're looking to get as much data as we can, especially through this winter, and then to understand how that looks as we add the second one on here in the coming months. You see a little bit about the vehicle that we have and what that means. I'll talk a little bit more about the pilot program specifically later on. But you know, the charging infrastructure was really interesting to me when Mike and I were talking about it, and I guess I didn't really fully understand everything that went into this. This is about a $95,000 investment just to get the 2 chargers installed at the facility, and we were fortunate because we had the 480 on site already. So there was about 200 feet of wire that we had to run, things like that really drove some of that cost. But you know, some of the cost that we avoided by already having some of this power on site was significant. The nice thing to test this and to think about this from a refuse standpoint is it's really a closed loop, right? We don't run into the same challenges as say a bus or things like that. It's the driver gets in the vehicle in the morning, he or she goes out, completes their route, and comes back to the end of the day to the same place after dumping, plugs in, and goes about their day. So we're really fortunate in that regard to be able to have that closed loop situation. We have these 2 ABB Terra 54 HV DC fast chargers. You know, the organization came out, trained everybody fully on how to charge, how to unplug, all of that stuff, and really one of the things that I was really interested in understanding when I was out there and sort of getting trained a little bit and seeing our drivers get trained was, you know, there is some trepidation amongst the operators as far as, well, what does this mean? Like, can I get shot? I mean, there's some legitimate fears and things like that from the operators that, you know, we found during the charging or during the training portions that was really helpful to have these folks on site, folks from Mack as well, helping us through this. So about the pilot project, you know, we went with Mack and the LR Electric because the reputation, our relationship with them is second to none. And also back to the operators of these machines, what Mack has done is really taken their existing chassis and all of their buttons and gauges and the operations and the mechanicals and things and added the electrification onto that same truck. So there's not a huge learning curve in terms of operation. There's some training involved in different things like that. But it's not as big of a lift as we were seeing perhaps with some other models. So we're really pleased so far with the training program. The other really nice thing that we found with the Mack was the maintenance program. So, you know, we can do things, all the standard maintenance, the trip checks and all the DOT things. And then MAC has a program that they just layer on to ensure that maintenance is taken care of and all of that. One thing that I would point out, so it's expected to allow for about 100 miles, and that's roughly 1,000 service stops on a full charge. I was looking back through some of our original documentation, and like GMP, we went through the Vermont's Volkswagen Environmental Mitigation Trust to secure some grant funding for the project. Some of that original documentation that we had was about, I think it said 50 to 80 miles at that point. So even in a couple of years, we've seen an evolution in the battery technology that has really made this, from my standpoint, a much more palatable pilot project, because now we can actually get to a place where we're approaching similar performance as the diesel machines. A really interesting thing about this is, so John in the picture there, I was chatting with him a little bit when we unveiled this. And you know, I think it's always good to get an operator's view of, you know, what they think about the vehicle going in, what they don't. And, you know, so he was sort of, you know, I don't know, I don't think it'll work. It's, you know, how could it possibly work? And then he drove it up Killington. And if anybody in Vermont or has been to Vermont and driven up Killington, you understand that, you know, how much that really sort of drags on your vehicle when you're going up. And he was amazed that, you know, the performance didn't change. So he got up Killington, in his mind, much easier, much more quickly than he would in his normal diesel. It took a lot more power and it drained the battery. However, when he was coming back down, he showed, you know, the regenerative braking was about a 30% charge on that same downhill run. So really, you know, whatever it cost him going up that mountain, he was able to gain it when he went back down. So that was a really interesting conversation that I had with John. He became a believer after a couple of days in the truck. So pretty good to see there. Again, we look at Vermont as the ultimate proving ground. We think it's the best place to try this out. We're grateful for the grant funding that we received to help make this a bit more easier of an undertaking from a capital investment standpoint. These vehicles run about I think it was 150 to 250,000 more than your standard from MAC. So there was that part that was offset there and allowed for us to make both an economic and an environmentally sustainable decision to go forward with this pilot project. So, you know, we're really excited to get it out there and get it tested under regular circumstances. You know, we're sort of cautiously optimistic at this point. I sort of kid with our operations guys. They don't like me having out in front of it because I'm excited about it. I love to talk about it, and they want to be a bit more measured. So until we have some more data to support, but so far it's an exciting time for sure.
Thanks. Thank you so much, Jeff, and really, again, appreciate you coming in to pinch hit for Mike. You know, one quick question. Well, first of all, I mean, thanks for recognizing that gap that many of us need to make between the technology and our end users. You know, when we're working with our public works, our municipalities, the folks in the shop are the ones who are using this and convincing them. And getting the feedback from them is really important. It seems like Mac and Casella have taken that into consideration. So one question here before we open it up to everybody else is, do you charge your refuse trucks to 100%, or do you leave some room for a regen buffer?
That's a great question.
Is that a Mike question?
Definitely a Mike question. I mean, and I'd be happy to circle back with that question by email or a quick phone call as well. But I'll get that to Mike.
Okay, yeah, I think that it might depend on the route. You know, whether whether you're starting at the top of Killington or not.
Yeah, yeah, that's yeah. I mean, in thinking about the route that this vehicle will be used on, it probably the answer is we charge to 100%, given that it's in Rutland City right out of the gate doing residential routes. But it's an excellent question.
Thanks. And then Sarah, you want to field some questions, or John?
Yeah, I think I have a list of some that we didn't get to answer, and please feel free to add more into the chat if you're thinking of some. Going back, I think up to Tom, we had a just kind of a comment and a question about the use of school buses in rural areas where a lot of times people will park buses at their drivers' homes overnight. So the charging overnight is less of a opportunity. Also, they were, curious about school buses that need to take sports teams to events on long trips. So if you've seen any applications, it sounds like you're really only saying in transit for right now, but just curious.
Yeah, typically the applications that we have mostly with regards to buses tends to be in public transit. That's where you have duty cycles that are very long, as well as operators who take 10 to 15-minute breaks during the day. And what we do is we work with the transit operator to place those chargers en route at those places where there are extended layovers or breaks, and where the routes kind of interline, so we can hit multiple buses at the same time. Again, with school buses, the challenge is that they sit for a period of time, and it's not, certainly we can equip the school buses if there's concerns from a particular district about handling high power cables. We could certainly work to equip the school buses, but the financials kind of lean towards longer duty cycles, such as transit applications.
Great. And if Scott is still here, I'm curious if you've seen any applications for school buses, because you could do sort of remote charging of the school bus too, I suppose.
Right. No, absolutely. So, so a part of Daimler is is one of the electric school buses. Also, we're working with Bluebird. Bluebird's coming out with a mobile electric vehicle charging for their school bus.
Oh, great.
They see locations where, again, it's sometimes leased land, or the need to very quickly get it up and running. So yeah, so we definitely we see a lot of electric school bus companies looking at it.
Great, thanks. And again, for Tom, I'm curious about any safety issues with the wireless charging technology, if there's any interference with, people with defibrillators, with heart conditions or other devices, since it's a high power.
Sure. Yeah, it's a common question. And every installation that we go through testing, because every configuration and every environment is different. And we've never seen anything that's been outside the boundaries that would affect, pacemakers, et cetera. Our most recent high-profile installation, I didn't mention this earlier, was Universal Studios Hollywood, where the electric trams, 2 of the trams there are charged by multiple units of our 250 kilowatt systems, both in the loading and unloading area. And as you can imagine, anytime you're, in an environment like that, there's extensive testing that goes on. And that was our most recent round of testing, which, again, everything was well within limits.
Great. And actually, that is a good lead into, is it possible to have 2 pads for one bus? So I guess that would increase the amount of power going to.
Yes. So at Universal Studios Hollywood, because you have a longer tram, we actually have vehicle side receivers on the front and the back of the vehicle. Because there has to be a lot of power applied quickly, because there's 3-minute unloading and 3-minute unloading windows, and they're very heavy trams. So we're able to essentially apply 500 kilowatts during the unloading 3-minute period, and then the tram moves up, and then it lines with 2 2 more pads. And while those passengers are onboarding, we provide another 500 kilowatts to the front and back over 3 minutes. And that actually allows, not only does that allow that tram to run perpetually at a high state of charge, because when you maintain that high state of charge, your batteries actually last a lot longer, rather deeply depleting them. But should power go out, which happens in California, there's enough power on those trams to create like 3 or 4 routes without circles without being charged.
Oh, great. And we had a few questions on the snow and ice. So I think I saw that if there's snow on top of it, it doesn't block it, but does it reduce the sort of ability to charge or speed with which it charges?
Yeah. Snow, ice, mud. There's no interference with any material such as that on top of the pad. And what you'll find too is that the front bumper of a vehicle, such as a bus, if the snow gets so high, it'll actually scrape off enough of the snow to where the remaining snow isn't a factor. So we have had a cold weather deployment in Salt Lake City. We are looking for trials in colder climates. So if there's anybody up in the Vermont area who's interested in a trial, please let me know, because we'd love to work with you.
Great. And I think last question for you, Tom. Can you say anything about the cost comparison with DCFC bidirectional chargers? What are they?
Sure. So if you're looking at those big overhead pantograph chargers in the transit environment, we're about cost parity, close to cost parity with those big pantograph chargers. When you look at plug-in chargers, they're more affordable. Considerably more affordable. But what you look at too is when you factor in, however, the total cost of operation, which includes somebody manually plugging those things in and unplugging them, and then you talk about the actual maintenance and operation, the maintenance or maintenance contracts that go with those plugins. In fact, what I'll do is I'll send a case study out, which will speak to some of this. That over the life of a 12-year bus, for example, we're much more cost competitive on compared to a plug-in charger. So you have to look at the whole, operating cost, not just the initial cost.
Great, thank you. I think I have a question for Tiana for Green Mountain Power. Are you assisting with grid battery deployment for on-site charging in Vermont to avoid infrastructure upgrades?
Yeah, so we actually have a couple of fast chargers on order right now that combine battery energy storage. So definitely something that we've been looking at. I mean, we're big supporters of battery energy storage, especially large battery energy storage. But yeah, something that we're always considering and looking at.
Great. So I think that all the other questions were answered in the chat. Peggy or Jessica, do you see any that I'm missing?
I don't, unless anybody in the audience wants to raise their hand and ask a question. Yes. Feel free to raise your hands and we'll call on you if you've got anything. It's just easier that way.
Yeah, looks like Austin Adams has a hand raised.
Okay.
Hi, Tiana. I was just curious about what product you were going with. Are you speaking to FreeWire?
I am.
Oh, you just answered me. I just saw it in the chat.
Yeah.
Perfect. Great.
And have you how many of those stations did you order? I'm just curious about your rollout there, because
I think we have 2 that we've ordered.
Okay.
Or are in the process of ordering. So I think it's about a 30 kW battery that's combined with that fast charger. And so that's one way that we're looking at it. There's another product that we've been contemplating that has a 500 kW battery, and it's and that is with EnerSys.
Okay. Thank you.
Great. Yes, Abby, the slides will be available in addition to the recording. We'll share those out with everybody who's registered. Brent, it looks like we have another hand up.
Yeah, thanks. This is a question for Tiana, I think. I heard Green Mountain was playing around with pilots with vehicle to grid. Do you have any
Yeah.
info on that?
Yeah. So we are working right now with the South Burlington School District. They have 2 clean school buses that we've seen backflow already from both of those school buses. So that's a pilot that we're doing in partnership with Norwich. And so, yeah, we're very interested in vehicle to grid.
No, it's excellent. Can you share any of the results so far? Just curious.
Oh, I don't have it in front of me. It's been, I don't even want to quote it because I think I'll get it wrong.
Well, maybe will be a follow-up webinar for us.
Yeah, it's great to hear you guys are doing that.
Yep.
Great. All right. So we have a few minutes left. We can just wrap up. We have one more poll question. Peggy's going to launch for us about connecting with your Clean Cities organization. It's a shameless plug for reaching out to us. And we can certainly work with you, and we bring a range of technical assistance and outreach to everybody. Let's see. One more question coming in as the poll's going through to Tiana. Maybe Tiana, you can answer in the chat there.
Yep.
Great. All right. So,
Yes, they are.
Okay, great.
Yep.
Okay. So it looks like the poll is wrapping up. Good to see. Many of you are, oops, now I can't see there you go. Many of you have already connected with your Clean Cities coalitions, which is really helpful. So Peggy, you can go to the next slide. I can just talk a little bit as we wrap up about some of the resources that we can bring to our coalition stakeholders. The AFDC website, I'm sure you may have all seen it, but please do check back often. They're constantly updating laws and incentives information for every state, and case studies, new case studies coming out of technologies. Their new vehicle search tool has been updated, and also with information about Made in America rules that are coming from the new tax laws. And of course, there is an A-Fleet tool where you can calculate the cost of ownership. So there's a lot of really wonderful tools on the AFDC website, and they're constantly updating, especially as all the new infrastructure money and is Inflation Reduction Act money is coming out. So please watch that space. Furthermore, we can, provide technical assistance, technical response service. We have access to a really wonderful resource where we can send research questions and inquiries, and we get really rapid responses from the technical response service with really in-depth research. So please always reach out to us if you have questions, especially about what other fleets or others are doing across the country. It's a really kind of central way to get information fast. And then our Tiger teams are really a secondary level, a more sort of targeted technical response. So we have lots of options for engaging and doing some technical problem solving with people that would like to get some of these new technologies. So thank you all for being here today. This is really interesting. A really big thank you to our presenters for taking the time. And please do reach out to any or all of us if you have additional questions or would like to get in contact with our presenters today. And Peggy and Jessica, am I missing anything?
No, thank you all. We'll be sending the recording, a link to the recording and a PDF of the slide deck. And then presenters, I think Tom, you had mentioned a case study. If you send that along, I'll enclose that as well as a link to the video. So any other information, please share. And then Jeff, if we can share Mike's contact, if they have specific questions that might be outside of your wheelhouse. I think that's it. So Tiana, Scott, Jeff, and Tom, thank you very much.
Thank you
Thanks,
all.
everyone.
Thanks.
Thank you.
Thanks, everyone. Thanks all.